All right, do this.
Great. Well, thank you so much for taking the time to join us today. We still have a couple people entering the room, but if you're ready, we can get things started.
Yes, yes. I'm sorry for my little snafu this morning, but glad we are all in.
No worries.
Um, all right. Okay, so yeah,
Fantastic. Well, thank you so much for taking the time to join another Balerion Space Ventures podcast. It's March 30th, and today we're joined by Joshua Okorie
yeah,
of Kodion. Josh, thanks so much for being here. We're going to be talking about the grid infrastructure and industrial power. Maybe to get things kicked off, you could give us a high level overview of what Kodion is doing to maybe someone who's never heard about it
yeah.
before.
So, anyways, th thank you so much for giving us the opportunity here. We so much appreciate it. So Kodion started as a tech company, beginning as a company that's big into the AI space, software development, anything you have to do with hardware, software integration, AI, mostly big into AI, a lot more AI emphasis. A few years back, prior to that, 15 years ago, we started with basically transformer design, anything with grid infrastructure, switch gears, transformer, last mile, anything that has to do with all that, all the full stack. And then we'll be working with companies like Snyder, helping them out with some designs, and some other companies that need some design work. 7 years ago, we decided to break ground, well, not break ground, launch our energy space so we can basically get out of people's removing the idea of consulting so we can actually go into as a product-based company. And then we're here now. So basically designing transformers, building a factory out here in Kansas where we actually manufacturing US made transformers.
Fantastic. And transformers, those are those big green boxes you'll see
Yeah.
outside of houses and buildings.
Yeah.
Okay.
Yes. Yeah.
So I've seen those throughout my life, and not a lot has changed with those. Where
Yep.
are we today with the service they provide exactly, and
Yes.
if they can stay sustainable in a future where we're going to need a lot more energy?
Yeah. Yes. So I mean, obviously it has remained the same, right? We've not had any big breakthrough on transformer manufacturing. It's been, like you said, the green boxes or the gray boxes and secluded areas that are substation driven. Um, this is where Kodion came in, right? We want to be able to look at that process and start changing that process based on geopolitical issue. You've got tariffs problem, you've got everybody this a lot of stuff going around the world right now. We're looking at the process like, hey, do we need that? Do we need this? Can we change this? Can we have a different process to be able to help out with this idea so we can start challenging some of these processes? Can we challenge this process in the build of this so we can be able to find, Joe Blue from a different city that can build this for us here in the US so we don't have to go across the country to get it. So that's kind of what coding is all about. We're trying to find a way to start challenges these processes and start asking questions and doing real life design work and also, research and also, actual build out to make sure that these processes are needed and what we need to change.
Yeah. And what's the state of the grid today, the power grid for the United States?
Yeah.
Are we falling behind?
Oh,
Do we need
yes.
to make a dramatic industrial shift? And if so, what is that?
Yeah, so yes, we're falling behind. And I think anyone you ask, depending on their political aisle, they'll tell you pretty much the same thing. US grid is not very redundant enough, is not smart enough, and also it's not resilient. We're in the big boom of AI where everybody's trying to, build all these data centers. And then now we begin to realize that we don't have a very redundant grid. And I think that's where company like us basically are coming in saying, hey, we can start giving that visibility. We can start trying to find, some kind of normalcy when it comes to redundancy. And also we can start trying to make the grid somewhat smart so we can be able to start readjusting and be able to have a little more visibility on the grid.
Yeah. And without giving away too much
Yeah.
proprietary detail, can you paint a picture of how your system is built and what makes it fundamentally new or
Yeah.
adaptive?
Yes. So anyways, Kodion, like I said earlier, we trying to find a solution to solve the biggest problem that we see on the grid. Um, After multiple designs and after being able to discuss a lot with our engineers, we realized that the actual issue the grid has is the transformers. If you look at data center companies, if you see like people trying to buy, have to trying to, be able to go do this anything with data center related, that's the first thing they ask, where do you get your transformers? This is the most important component on the grid. So with that being said, Kodion basically we zoned into that. Our components, our copper, our aluminum, our bushings, and our cooling, right? That's what you hear about in anything, that's kind of infrastructure, even in data center world. Um, Kodion decided to come up with a different technology with bringing all our experience in AI and also obviously hardware. We solved the problem of cooling so we can reduce that footprint. And that was the solution for us, and it works. Think of it this way: if I need to, if I need to use 150 MVA, um, and I know that I can only get 100 MVA, how can I get 150 MVA from 100 MVA and be able to handle the heat? Kodion found a solution for that while also reducing the footprint. We came up with a proprietary cooling system that will potentially, that is actually, it's not R&D, it's actually a product now that is cooling the transformer down and also reducing the footprint. We're removing the radiators, we're reducing the tank space. Now, this is better in the substation world where you actually have space is very much important. And also the cores are bigger, so then you have to have a more compact tank and remove the radiators and the fans in the back to allow for overload. And we're able to crack that by actually introducing a cooling system that can be easily serviceable in the US and basically be able to handle by any HVAC company in anywhere, any city you are.
Got it. So with the large shift coming to the energy infrastructure grid, what does
Yeah.
that look like? Are we taking these transformers out, we putting new ones in? Are we just adding more? How does it going to look in 5 years, 10 years from now?
Good question. So we can retrofit old ones and we can put new ones. We're doing a lot of retrofits right now with some clients that we have. And we are able to be like, you know what, we can put new ones in there. We can retrofit old ones, or we can redraw it, depending on what you want. Maybe it's a question of, I mean, can we get 20%? Can we get 120% on our current demand? Can I say, hey, um, there's a 150 megawatt demand, and I can give you a 100 megawatt transformer. You can get there and you can stay there. Or can we start rethinking the grid a little differently? And I think that's the questions that we create. But the most important thing is we have the data to back it. We have a visibility, we have the eyes on the transformer, we have, an AI based system that is collecting this data in real life and actually making decisions based on this data. I can tell you the failure point of a city. I can tell you the failure point of a state. I can tell you how to modernize that state based on the data we can put in. I don't have to tell you to go buy a new SCADA system. The SCADA system is coming to you inside a transformer.
So do these systems right now, when I see a green box, it seems like old technology. How are
Yes.
they communicating with one another? Are they smart yet? Do they need to be smart?
They don't communicate with each other. That's a good question. Now, right now, there is there are outside component you need to add on a component, meaning like we call it SCADA systems, right? Where you can come and be like, hey, I have a green box. I want to communicate with it. I have to put in sensors. Our transformers comes with built-in sensors with this SCADA built in into it. So you don't have to actually make those changes. So if a Kodion transformer comes in front of your doorsteps, you've got temperature sensor, you've got pressure sensor, you've got voltage sensors, you got PTs, CTs collecting data in both sides of the aisle and doing comparison based on this data and start checking the heartbeat of the transformer. And then you got pressures, you have sensors checking the cooling of the core and be able to handle the overload and trying to make sure that the overload is meeting the spec of the transformer, making sure the cooling is meeting the spec of the transformer, and making sure you can scale more. I can tell you, hey, I think right now you're maxing 120%, go to 150, you're good. The transformer is handling it. You can start getting that information in real time instead of just waking up one day and your transformer burnt up. So we don't want to avoid that.
Got it. And with how the grid is structured right now, what would you say some of the biggest bottlenecks in energy infrastructure in the United States are, that just won't hold up in the future of we have large data centers, we have a lot more power.
Yeah.
What's like the key area that needs to be fixed before we enter this next generation of energy infrastructure?
And I think that's where you can tell you can any every hyperscaler and any data center developer you talk to right now to tell us that same thing, transformers. Period. We're not able to move fast enough. We're not able to get away the geopolitical problems of sourcing copper, aluminum, or steel. We're not able to be very reliant on ourselves. We've not been able to say, hey, how can we start manufacturing and have a steady copper manufacturing process here in the US, or no, I'm not talking about in small quantity, compete with China, compete with other part of the world that are, spitting this out in tons and tons an hour. Um, I think that is where our issue is going to get to. We realize that we cannot move fast enough anymore. And that's where Kodion is coming in and trying to, plug that bottleneck. We have a steady R&D department that is doing steady R&D on, modernization of copper manufacturing process or steel or transformer oil or the most important component that is needed in a transformer, bus bars, aluminum conductor, copper conductor, steel, silicon steel with electrical steel, high grade, low loss electrical steel, and stuff like that. We're trying to find a way to start building those here in the US and and start solving the problems of global warming or being able to run these things need high heat. You have to heat up a lot of stuff. So we're trying to find how to do all the carbon capturing process so we can have cities in the US be okay with these plants being erected in back of the yards.
Got it. And where do you think we're going to need to see most of these new plants scale up? Is it a future where there's nuclear reactors all across the United States and they need transformers right there? Is it have to be a key detail when there's a hyperscaler building an AI data center? I'm sure all of these are important, but
Yeah,
as it's new and coming
yeah.
in the future, what are some of the choke points we have to address first? Like, well, we have to figure out where we're getting the power from, or we have to make sure this place that's using the most power has the best transformers and reactors.
Yes. So, I mean, really, it's going to be just anywhere in the US. The question will now be, how fast can you crank up a transformer? How fast can you get me a substation that is 150 MVA? Can you crank that up in 2 months, 3 months? Can we bring that down? And I think once we start answering those questions, I think our looks on how we can change the grid to be smart or how we can change actually the how fast we can erect these data centers and solve the power problem will change. Because if you tell me that I can get you a transformer, a substation that is not going to take 1 year, I can get it in 4 months. That means you can be able to get your thing ready, turnkey, and be able to start solve your problem with power and not having to cause have any issues or make sure you can take your utility space very well. So I think that will be the question we need to answer. And to answer it directly, it doesn't matter in the US where we have. I mean, we are right now located in central in Midwest. We can get to anywhere from here. We can get to any part of the nation from here. So it makes it easier for us to get to places. And we're also open to go to other places and put factories out there too.
Got it. Um, let's go back a little bit. What was the point where you decided, you needed to step in and create Kodion, and this is the direction it needed to go? How did you end up in that position to where it made you create that massive shift of saying, you know what, I can do this. It needs to be done. This is the opportunity, and I have the solution.
Yeah. So and that's a good question. I think that idea came out 7 years ago. Um, Coming from a country where power and energy is a problem. I'm originally from Nigeria, where people study with lanterns. Uh, when I came here, the idea that I had about America and the energy was different, right? I thought that America had power, which it does. But once I got into the energy sector, I realized that it has limitations that those limitations are getting close to being met. And And we saw the issue very easily on the design. When you design transformers, you design all the spec, they look exactly the same. You start seeing the weak points as an engineer. And then when you start having all your engineers saying, hey, this weak point, this weak point, this weak point is here, and you start figuring out, okay, I have to buy my radiators from this country, I have to get my oil from here, I've got to get my copper from here, and then you start realizing that, okay, maybe we're not as maybe we're very dependent. We need these people, we need to have these assets, and we need to play ball with these companies and these countries to be able to get raw material. We start changing our mindset on that. We said, okay, we need to solve this problem. We need to solve in the US. We have to UL list it. We have to put the standard on it, and we need to call this a new standard. And that's how we changed the process on that. We manufacture transformers. We've done work with the for the DOE. And we're able to build these processes, test it, make sure it works the way we want to make it work, and start competing and trying to be able to benchmark this with other companies and other products.
Got it. And can you highlight some of the key milestones you've hit over the time the company has been created to now?
Oh, we have customers. We have been able to. We have a small, currently right now, a small facility, a small footprint, around 10,000 square foot. We're building another 120,000 square foot is ongoing. We just had a groundbreaking a month and a half ago. And with that 120,000, 125,000 square foot, we are able to have a lot more output, around 4,000 substations a year, and probably around 10,000 power mounts a year, which is a lot. And then with where right now, we've been able to do work for solar projects with DOE, and then we are working with some oil and gas companies up in Texas, where heat is a problem, and then our technology solves better there than everywhere else.
Got it. Um, Maybe you could give me a high level explanation of how the grid works. How many places are generating power? What style are they using to usually get power, whether it's solar or coal? And from there, where does the energy go? And I'm sure it distributes and then distributes and it grows into a grid.
Yeah,
So walk us through the starting point of where energy is created and how it gets to powering my house.
yeah. So obviously everywhere is different depending on what utility you're using. Then the energy will start first from what do you call it, uh your generation plants, right? It goes up, and for energy to transfer, just to break it down a lot more, for energy to go long distance from there, they have to run it through a high voltage line. So you're talking about something as high as, I don't know, depending on where you are, 138 kV or 345, or even some part of the world in the 500 kV. And from there, it will run all the way down to we call it last mile in here in Kodion. It will run to down to your area, and then it steps down to a smaller transformer, which now comes down to your house. I think most houses in the US are 208 um, volts, or yeah, if you have a factory, or if you have a industrial area, you got 483 phase, and most of your houses are 208 single phase. That's what you have in your house, your 220. Um, and then basically that's kind of how it goes. You travels from the what do you call it, from the uh generation plant. It goes high voltage, it goes all the way down to your house, it comes back down, and then it will basically steps it down to the voltage you need in your house. So what data center companies are doing is, now obviously that's separate. Now if you have solar, that's different, right? So solar you can do bidirectional, where you basically have your solar generating and then grid, and you're selling, you're taking back, you're charging your batteries, you're selling, depending on the demand and stuff like that. And everybody's different. And I've seen different companies, I've seen different data center companies doing something different. They have solar, they have a hybrid of that, they have batteries, and they also have basically their own generation plant where they're trying to be independent and be able to do their thing. So it all depends on where you are and what you're trying to do. But for the normal sense of for the normal person, it goes from the generation plant, it comes right down to your house.
Got it. What are some what are some things that people often underestimate or don't fully understand about building in this domain?
Um, I mean, just all the craziness, the process. And I think for us being in this space and having engineers that work here at Kodion, we have to look at it that way. Everybody's different. Every client is different. Every place you go to have different processes, or just the standard. Now, if you're dealing with people in the Middle East, people in Africa and America, everyone is but these standards are very necessary. These standards are there to make sure you're safe. They have to make sure that you don't overload your transformer and you blow it up. Um, and that's kind of what we see with everybody. And obviously, people just underestimate how hard it is to get component. Anybody can go out there and say, "Hey, I am a data center developer. I have this great idea," but actually, when it gets down to it, they realize, "Oh my God, it is going to take a lot for me to get connected to the grid. It's going to take a lot for me to have this amount of power. I can talk about how much gigawatt I want or how much megawatt that I know I want, but when it comes down to in paper, you're looking at years to even get something going." And I think that's where, and I will say it openly, if you are remotely thinking about doing anything in the data center world, you need to get yourself immersed in a company that can help you from the ground up. Now we are helping companies all the way out here when they've made all the mistakes down here, and we're trying to clean all that up so they can make their hyperscaler happy. You got to start from here. Get yourself matching with a company that has, I call it the full stack company that can do design and build like us, and can actually understand how this works. Hey, you don't need this transformer, you need this transformer. You need to do this, you need to change this, you need to change that. We can do this. You cannot get this. It's custom. It's going to take another 1 year. That is what kills people in this space. Start from here. Find a company that can help you. Partner up with a energy firm, an EPC firm, whatever you got, and be able to uh, understand the process, then present it so when you go to your hyperscalers, you can understand what you're building. So you don't have issues with your turnkey solution.
Got it. And as a lot of people are aware, the future of data centers, that's going to require a lot of power.
Yeah.
What are some other areas that people aren't aware of that require a tremendous amount of power, either today or possibly in the future that maybe isn't being talked about as much?
Manufacturing. I mean,
Manufacturing.
how you gonna build all these data center component? You got switchgear companies basically can't get switchgears. You have transformer like us. We are here building a factory currently, and we're talking about our power. We're realizing, oh my God, we might not have enough power in the city for our stuff. We overlooked these things, and then now we're having to change our mindset on the component we use or what kind of hardware we're gonna have so we can meet up and be able to not overload our city. And you gotta talk about it. Manufacturing is gonna take a lot. You have the AI boom. After AI, you're gonna talk about robotics and bots. Having because that's the key, right? You've got the AI, and then you put in the hardware, and then you be able to do like some manufacturing work instead of needing 20,000 manufacturers. You can have, I don't know, like maybe 100, 2,000 bots doing the work if you give them the eyes and you give them the everything they need, and with AI they can do our work. So how do we build that? A new kind of manufacturing will start. And how do we sustain that and AI? That's the question that I believe that everybody's trying to solve right now. And that's why you're having people like spinning their wheels, and transformer companies are trying to come to the US. But starting a transformer manufacturing company in the US is not easy. You have to be here to have that little ramp. To come from overseas here, you got to move. Not every electrical engineer is a transformer design engineer, and that's what understand is a special trade. And we figured that out. We understood that, and that's what we'll be able to get through and hiring the right people.
Got it. Okay. Um, so the manufacturing process of building these transformers, what's that like? How many are able to be produced in a single factory over the span of a month? And is there anything that's slowing it down, whether it's supply chain, raw materials, or partners with
Yeah,
the bill of materials? Certain parts are
yeah.
hard to get.
Well, the a good question actually. So the how much you produce right now is going to come down to how fluid your team is, and how you look at manufacturing. Most people look at manufacturing on the scale of how does the Chinese do it, right? How does the Philippines do it? Um, it's not like that. We cannot look at manufacturing like that. We live in the US where you cannot get cheap labor for $5 an hour. We live in the US where we don't have the population. We live in the US where everything is very standardized. You cannot walk people, and there's unions. There's a lot of different things that can affect that. We have to look at manufacturing in the US in the sense of AI and robotics, and I think that's where everybody's headed. It might not be talked about a lot, but that's the direction we're going right now. You got people trying to build all kinds of bots out there, building humanoids to be able to allow, replace the human hand that doesn't get tired, like, working a certain process, because we don't have the labor. We don't have the laborers stacking transformer cores like slices of bread, and that's hundreds of thousands of it. It's not possible. We can't compete with China. China has us beat. So the process of building factories by looking at the Chinese is not going to work in the US. I think the thinking has changed. And I think that's where we as a company, we have an office in China. We are studying them. We are studying the way they work. um, we're changing that process because we're saying, okay, if they walk like this, we gotta walk like this. I cannot get 10 people to walk 20-hour shifts, or sorry, 15-hour shifts, walking like crazy for $5 an hour. I've got to replace it with this machine so I can be able to meet up. But I have to make sure that process that I'm putting machineries in cannot be it won't be a bottleneck in the future. It will not produce something that will have a huge dependencies and have issues. So I have to be very smart how I use humans, and how, where I bring in robotics, where I bring in automation and stuff like that. So that changes the way we produce. For us, 125,000 square foot, our output is going to be 4,000 substations a year, which is pretty good output. Probably around 10,000 part months a year in that one facility. We plan to build multiple of those.
Got it.
And the bottleneck is funding, right? Anybody can have an idea. Uh, Anybody can have a great idea really, but once you actually get in the lab and trying to build it and start trying to scale, you realize that that idea has a lot of holes. And then having the money to move fast is always the key. So you can be able to get through that process and be able to get what you need.
Okay. I see a question from the audience. As talking, solar can scale very well locally. What is
Yes.
the global limit of solar on Earth in terms of land, storage, and stability?
Well, I mean, I know that in Africa you don't have any. You can build as much as you want if you have the space. But here it's gonna come down to, are you having an infrastructure where you're putting up 1.5 gigawatt, solar, and can you sell it? Can you use it all? Do you have battery? That this all these questions comes in. Can you store the excess energy when the sun is blasting in the daytime? Or can you sell some of that to the utility? Can they buy it? How much can they buy? Then that is the questions that started becoming a real question mark for a lot of solar developers right now. And I do see a future, a hybrid situation, and it's already out there, of some kind of bi-directional movement where you can be able to have this solar, this battery stack, and also grid. So you can reduce your reliance on grid to when your batteries are not full, or when you need to buy the energy when it's cheap, so you can be able to use it when it's expensive. I see a hybrid of that, and I think that's the future. If we can get access to solar panels, and if we have access to the land, and these are all the situation. But again, it depends on who you ask. For me, I think it's lucrative. I think if you have, you know, a lot of acreage, and you want to be a solar developer, I think you should scale that way. Build your business model, modularize your data center solutions into using some kind of hybrid situation like that. It will probably give you a lot easier turnkey solution than
Yeah.
building it with the grid in mind.
And going off that, another question from the audience is what does the energy system look like when AI, cities, and industry all scale together?
I think it's great. I mean, depend. I mean, I think it'll be good. I am a huge advocate for grid awareness. I'm a huge advocate of your last mile communication. I do believe that in a world like this, I should know how much I use in my house a second. If you look at your phone, and I know there's a lot of things out there for, like, if you have a power wall or something like that. But when it comes to grid, I need to know how much my transformer is losing. When the power gets to the transformer, it has losses. How much is my transformer losing at a time, at a period of time, versus how much am I taking from that transformer? I think that is a solution that we need to implement. And that's what Kodion can solve. We want to give that solution. I will tell you, the transformer has a loss of 50,000 watts and you use 20,000 watts. So really, I mean, who's paying for it? Who's paying for the losses? These questions are things we need to start asking. We have to nickel and dime power, like you save money in the bank. That's how it's supposed to be. So we can make sure that we're building transformers that are efficient, low loss, and then we can make sure that we're not wasting power on something that is not efficient.
You know, what does the future look like if geopolitics get, there's more tension and maybe adversaries start sending bad actors to the United States? And I'm sure one of the key areas they could hit is our energy.
Yeah, yeah.
How protected is our grid? What do we have to really acknowledge and be aware of? This is a key area that threats are high and must be protected.
Well, right now, our grid is not protected at all. And when your key commodity, copper and aluminum, is imported, you don't have any power. When they shut that down, how fast can the U.S. be reliant? How can we, how fast can we move in making sure we can get the raw materials that we need to make sure that transformers are getting cranked out? We don't have that bandwidth right now. Any transformer company that says that they buy copper and aluminum in the US in huge quantity, they need to tell me where they're getting it from. It's just not. So that's one thing that we don't have. That already right there puts us in a very bad situation as a country. And I think that's if you look at the what is happening right now, it doesn't matter where you are, in what aisle, Democrat, Republican. That's something we all agree on that the US needs to have a little bit more power. And that comes with the tariffs, where it's forcing manufacturing companies say, oh, wait a minute, maybe I need to go start building this, start building that, so I can not have to import it. It's costing too much. Or maybe we can be able to start looking within. I think where we're not doing a very good job in is being able to not starve the energy industry of something they need and start producing it. We're not doing the production side. We don't have the infrastructure put in place to say, hey, who out there in the US can build me a clean way of making copper? I will pay all the money to allow you to do that. We're not answering that. We're not asking those questions. We are just putting tariffs on high component. And I think that's where the energy department right now, DOE is trying to spin off and trying to support some of these and trying to be like, you know what, hey, by the way, we need to start putting money in manufacturing facilities that are willing to stay in the US or that are willing to move their manufacturing in the US. But knowing what I know about energy manufacturing and transfer manufacturing, it is not easy for a company to move their transfer manufacturing from India or China to the US like that. It's not easy. It is a very hard process. You're not moving the actual manufacturing. You're moving your technology know-how. You're moving your engineers. You can't find those in the US. We don't have those guys here.
So, what do you think the solution is of what we should start putting our attention in? Does it start with the DOE? Does it start with mining more raw materials?
I think we need to look at exactly where does our ethical belief ends when it comes to mining? What do we call bad, or can we stretch that a little bit? And also, can we invest in companies that are willing to do these things, or can we meet in the middle where we say, okay, you know what, you're gonna mine, but you need to meet these requirement. You're gonna build steel. You're gonna crank it up. You're gonna be smearing and heating up and having a lot of carbon deposit. But we need you to capture it. Like there's got to be something we need to put in place to meet all our the environmental factors. We don't want to cook up the city where you have black smokes up in the air. We don't want to do that. We don't want to stink up the city like it is in Beijing. But we can find a solution in the middle where we can bring this processing in and start competing with countries out there that have their hand on these raw materials. And we need to start making deals with other countries to get raw materials, copper or silica or something we can get from other places and start being able to start becoming a lot more independent on this in this stage. And also the government need to invest money on potentially, or investors need to drop cash on companies that are willing to say, you know what? I don't only produce transformers. I'm gonna go in to get my raw materials. I need to have power in this. I need to have I need to be able to control this raw material.
Got it.
And also we need to start asking questions like, how do we remove things that are basically 100 years old that nobody's looking at? And I will show you a little something here from my screen. And I'll speak a little bit on that if you permit me, obviously, to share.
Yeah, absolutely. If you have something that you can share that can easily walk us through this, I'd love to take a look at it.
Yeah.
And mind you, we have a lot of people who will listen in on this and maybe
Yes.
not have the video, so we can talk about it briefly, but maybe not spend too much time on
No,
it.
no, very briefly, I'll run through it very quickly. Let me share. You can see my screen. Let me know very briefly.
Yes, I can.
All right, and then when we talk about the cooling, when you look at your traditional transformer, you see the radiators in the back of the transformer. And for us, we are removing that on other Kodion transformers. We are actually replacing that with a cooling mechanism that reduces the weight of the transformer by cut at 40%, and that's 40% of steel that we use less in the transformer, and we're able to start allowing the HVAC companies that are behind your houses or down the road from your house to be able to service this transformer that way while the transformer is energized. That was our solution. We can cut down the oil, cut down with the tank, cut down with the steel that we're going to use on these transformers, and be able to allow remove the dependencies of having to import radiators from China or anywhere else is being made and be able to have that power.
Got it. I'm seeing some questions from the audience. One is there's talk of DC to DC power beaming via microwaves can be, around 85% efficient. Is this a potential bypass around copper infrastructure?
Yes, I mean I think there's a lot of R&D on it, and there's just not being. I had one of my engineers was talking about it last week. There's not been a big something out there that could use it. It's not about building it, and I think that is the idea we're running into right now. Is the idea is great, but can you make it bigger? Can you use that some idea on a bigger system that's 100 MVA, 140 MVA, and we have standards we have to meet. So I think we're very much very far away from that.
Got it. And then I see another question. If US power demand approaches 1 terawatt soon, what energy sources realistically supply it?
Uh, I don't think it's gonna be solar. I don't think it's gonna be wind, although it will be helpful. We can keep pushing it, but there's a lot of again geopolitical tensions on those. And I think we're gonna end up being it's gonna be a lot of nuclear, and I think that's gonna be the solution here. It won't be coal. I think that's where we're headed, having a lot more mini reactors that can give us this power. Now, I might be wrong. We could still have, solar developers, but like, I mean, you need a lot more acreage to be able to have all these panels lined up. So that there could be a issue with space on that. Wind is a potential thing. I mean, we've seen wind working well in Europe and some part of Africa. So like, there's a potential that we could use wind can crack this for us. So, but I'm thinking it's gonna be nuclear.
Got it. And maybe a lot of people don't know, but our grid system, we don't have that many. We only have like a handful of grids across the United States. I think there's three major ones and maybe some microgrids in
Yep,
Alaska and
yep,
Hawaii. Do you see a future where this changes and microgrids start scaling and we're seeing more of
yes,
those across the United
yeah,
States? If so, how
yes.
does that happen?
Um, I think it's gonna come down to thinking, right? So I'm from again Nigeria, where the microgrid system is what we are implementing. Kodion, we have a 100 kW a solar farm that we put in place for kind of a proof of concept of what a microgrid will look like. You have 50 different 50 different 50 kW different patches where we're trying to build a smart grid system that is a microgrid, estate based. Now, I think the US will end up heading that direction, and I think it's gonna get down to getting used to. But I think it's gonna end up in a situation you have microgrid system that are scattered across some area, and then having some kind of smart grid system that is basically circling it. so you can have redundancy. I think that could be a thing, and I personally think that's what the U.S. grid is gonna probably gonna be a lot more resilient.
Do you think that we might see something major and dramatic, maybe bad, happen before we start seeing the pace of this industry shift?
Yes,
Maybe
yes.
something like what happened in Texas?
Yes, we're gonna have well not I mean that and more. A huge great sabotage. Somebody's gonna wake up one day and sabotage one of the substations or power plants, and then we lose a lot of power or even war. And I think that's gonna end up being we've seen that what happened in Ukraine. You see what happened in Iran over the weekend. They took out one of their substation. The whole Tehran was in darkness. And stuff like that could potentially happen. And I think that's where you start thinking, okay, we're not, the little lights we have in our house and a little, we're just not, it's not what it is. It takes one guy to go take a gun and shoot up some places and then we don't have any power. And I think that's what it's gonna take. But what happened in Texas was eye-opening. But I don't think it was dramatic enough. I think it has to happen for like a multi-state outage or something like that for us to start waking up.
Yeah, the scary future, and I think a lot of people have started investors to backing, you know, not diesel generators, but micro power stations
Yes.
with energy. What's your thoughts on that and how effective it can be for emergency situations across major cities?
It'd be good. It'd be good. I think those also work very well in a microgrid solution too, if you scale up properly. And I think that will work also for yes, obviously I think it's being used right now for my data centers to be able to use as a kind of a UPS solution where there's no power, wind power for a kind of a backup solution. But I do think that it could be a solution that we can scale up. Again, I go to all these energy seminars, I go to all these new techs, I go to all these chemists of new battery techs, I go to all these, mechanical battery tech designs, and the question always comes down to how big can you make it? Are you trying to power your small house or trying to power cities? So I think that would be a solution is can we make it big enough for us to be able to realistically sustain a city or a huge data center or something like that, or a campus.
Got it. I see some questions from the audience, quite similar. Would Kodion's transformers be integrated with micro nuclear reactors linked together to power data centers? And could we bring energy to data centers or data centers to energy?
Yes, good
Two
question.
questions there.
And actually, that's a very great question. We have and I can talk more about it. We've been having some conversation with the Department of Defense recently on some situation where Kodion transformers are going to be paired with actually a device for EMF, basically. And I think that's the first thing that probably is going to happen. Being able to have protect the transformer from you know very, very bad thing happening in that sense. So that will help to reduce having a situation where the grid can be taken out by just a big pause. And that will be a solution that Kodion is going to be offering in their transformers that I think will help the data center world if there's a sabotage where there is a big EMP out there, and then it takes out a transformer. And that could be very fast, and that will be I think the next it will be kind of what you start seeing a lot in the next warfare where people will just use a huge EMP and take out transformers and stuff like that. We are working with we have some solution I can talk more about this right here in this call where we are trying to provide a solution that will be paired into our transformer to protect the transformer from that kind of stuff happening, mostly in the military side. And then for actually pairing with other systems, yes, we have solutions and we have some actual renderings we put out in the past looking for investors to come in with a solution where this is built in with a battery technology and inverter all together that can be shipped out in a transformer base, sorry, in a container base and dropped out in campuses that can actually be a turnkey solution where you just plug in. It has, the chemistry there, either lithium or zinc bromide or Balerion flow, where you actually just have that backup for that campus for as long as you need it. Um, but I don't think we are going to have a solution, or we don't have any conversation with anybody that have a nuclear or a mini reactor that can interface with Kodion transformers. And I'm open to that conversation. I'm a huge advocate for anything alternative,
Got it.
nuclear,
I see it.
solar, or wind. I'm a huge advocate for that.
Yeah. And I see another question. if we connected Earth's day and night power grids, how much efficiency do you think we would gain? And could electricity become a global currency?
We're going really deep on this. It could be a global currency, um, but it can also be a big problem, right? So if we connect everything together and then tomorrow I start having a fight with you, then what do? You cut me off. So so we I think a global currency it is the biggest commodity in the world. Without electricity, you have no manufacturing. And without manufacturing, you don't have economies. So um I don't see that ever happening. I think we are most likely going to be trying to solve problem independently, especially what's going on with Ukraine and now in the Middle East. Everybody's going to be very wary for a while on how of being independent. I need to be independent. I need to make sure that I don't choke myself. I don't have people choking, crude oil stuff like that. I think that's going to be the conversation for another 20 years after this will happen. There's no friends. If I'm your friend and I can choke you with electricity, I will choke you with electricity.
Yeah. Um, so going forward, what's the next, 12, 18 months look like for Kodion? What do you have planned for the future?
Good question. For us, again, is being able to move through with the funding of our facility. The facility is ongoing. Kodion becomes a totally different company with 124 25,000 square foot. That's you can do so much on where we are right now. We are turning down work. We are not able to take on new clients. And we're looking for a very good partnership with any, hyperscaler or data center that's really, really ready to solve the problem. And I say this I have had multiple calls where we met with data centers and had conversation one in luncheons and one-on-one with them. I said the big mistake you make from beginning, like I said again, is not getting an electrical or a firm like us, a consulting firm from the ground up. Make your decisions around that first. And I think some people are doing it, but some people are also waiting until they go through their process and they do it in the middle. Start from the ground up. And we want to be partners for these companies that I want to do. We want to be reached out to and say, hey, help us. Let's help you with the conversation going forward. Let's supply your transformer from you from the ground up. Let's understand your need and also give you the leeway and the tolerance to handle more. And I think that's so you don't trying to figure that out after you've been funded and you're figuring, oh my God, I can't get transformer, I can get copper, I can get switch gears, and then your project is delayed. And I think those conversations needs to start happening from the get-go. And we want to be that solution. In 18 months, we want to be able to, flood the US market with substations, help every data center company that needs the help and be able to, be the, true solution here in the US. And we're trying to be proud of Made in America. We are very excited to Made in America. We will always, always find solution in America first. And if we can't find a solution, we will find a way to make sure we are the solution, and that's the solution for us.
Yeah, absolutely. Um, for investors thinking about this domain, what key indicators do you think they should look for to separate the hype from genuine technical breakthroughs?
Yes, and I've seen that a lot. You meet all these guys that have a huge hype of like, oh yeah, I have some data center ideas, and 2 weeks later they're broke. They can't figure it out. They can't move. It's a lot. And for us, we have to sit down and look at it. Okay, are you funded? Don't show up and tell me you have all these things. But I can call it by just having a conversation with you. I'll be like, this guy doesn't know what he's talking about, or they are very naive on this process, and I can back out as a key supplier of transformers. I don't want to be able to put in my manufacturing on the line, not knowing that you can't be able to afford to pay for it. Um, so I think the to be able to know if it's a hype or real is you got to involve a company like us. Go through the process, talk to the developers, understand what exactly they're trying to do. Do your research on where they gain their land. Where are they getting where they trying to put this data center? What is their process? What is their power requirement, and how are they bringing the power? And then also the other things are a lot easier. You can figure out the rest out how to get the racks and stuff like that. But the power, it is the most important thing. And I think that it'll be very difficult for somebody that's a hyperscaler trying to drop a lot of money. I think it'll be difficult for them to see that if they don't involve a company like us too.
Yeah. And yeah, through this conversation, I've just learned about, a lot of barriers and things we have to figure out going forward into the future of things scaling. I want to get your take. If you could wave a magic wand and fix one systematic barrier of the energy ecosystem, what would it be?
It would be being able to have access to key component in transformer manufacturing. I need copper like tomorrow. I need aluminum like tomorrow. I need steel like tomorrow. And I need a lot of it. If you can solve these three problems for me, and I think whoever solves that problem in the US when it comes to getting copper conductors for transformer manufacturing, silicon steel for your electrical steel for your transformer motors, whoever can solve that problem single-handedly in the U.S. Ecosystem in our geo area inside the walls of the United States, that person will control the energy market. Mark my word. Any company that solves that problem will control the energy market, and we're trying to solve that problem. We've realized that everybody's trying to. Hitachi have the problem, ABB have the problem, Howard have the problem, Eaton has the problem. We are all getting our stuff from the same place, and that is the real issue that's increasing the lead time on transformers. If I can wave a magic wand, I want to solve that problem right now. If you ask my engineers, they'll tell you that I am a big dreamer, but I got here dreaming, right? This whole thing was built on a dream. One day, we're going to be able to solve that problem too.
Absolutely. I love that. Well, this has been a fantastic conversation, Joshua. As we're wrapping up from our conversation and people listening to it, if there was one big key takeaway you'd want them to walk away with, what would it be?
Keep dreaming. If you're here and you have ideas on how you can solve the energy problem, reach out to me. I want to listen to you. I'll make time. There's always a smart thing in between every dumb thing. And being an entrepreneur like me and being a working engineer, I am not only the CEO and owner of Kodion, I'm an engineer. I'm in the factory every day, all day. I'm innovating. I'm young. I have a lot of young engineers here. I would say if you're listening to this, always keep dreaming. Your solution could be a solution that we need. And if you want to run this solution through somebody, I am open to have this conversation with you. And let's see if we can put hands together and solve the problem. I'm a nerd in hat, but I'm a business person too. So, but I'm still a nerd. So we're trying to find a solution to all the problems. And then we leave our doors open for people to come in and, compete and also even challenge our processes. Why are you doing that? How are you cooling the transformer down? Why are you putting a 1 ton unit, a 10-ton unit on a 100 MVA transformer? How is your algorithm written in Kodion? How do you build your cooling system? How does the AI work? How does your AI work? How does the SCADA works? How do you predict the grade? What is the future on Kodion AI? I want to answer this. I will obviously, if I can, in some proprietary stuff, but I want people to ask these questions, and I want to be able to be, a conversation, not a challenge. I want to meet everyone in different aisle and sit down and have an intellectual debate on some of these things.
Absolutely. Well, Joshua, thank you so much for taking the time to join us. This has been an amazing conversation, and I'm really excited to see the future of Kodion.
Thank you, man. Appreciate it. Thanks for having us, man. I appreciate it. Thank you so much.
Absolutely. Thank you, everyone, so much for joining. Take care, and we'll see you next time.
All right, guys.
Bye.